Hello, Matthews Gatos here. Welcome back to section 7.3, part 2. Before I get into the part 2 video, I want to review part 1. So solving graphically. So to solve this graphically, what you could do is pause the video, try this question, and come back to see if you did it correctly. So if I want to solve this graphically, the first thing I want to do is set it equal to 0. So I'll keep the absolute value where it is, but I'll subtract 2 from both sides and set it equal to 0. When I subtract 2, remember it's outside the absolute value. So what I'm going to do is put this entire equation here into y1 and this into y2 and look where they intersect. Because I am solving it graphically, I need to provide a detailed sketch of the graph. So I want to label all the important parts. So here's what my graph looks like, and notice I have all my intercepts and I have all of my vertices and y-intercepts, maximum points, etc. labeled. So now that I have my graph, it's just a matter of reading the graph and identifying what my solutions are. So my solutions to this, since I set it equal to 0, are the x-intercepts. So stating my solution, I'll just do it from smallest to biggest. It would be negative 0.6, 1, 2, and 3.6 would be the entire solution. Okay, so in this video, we're going to look at how to do it algebraically. So here are the steps that we're going to follow to solve something algebraically. First thing, just like we did with radical equations, is we're going to isolate the absolute value and write it as a piecewise function. So as soon as we isolate the absolute value, we have to look for any implicit restrictions, remembering absolute values are positive. And if I have an equation on the other side, that also must be positive. Solve each equation in the subdomain. So what you're going to do, in other words, is replace the absolute value with each of its piecewise functions. Then check the solution. Check it in the subdomain, check it with the original restrictions, and always check it on the calculator with the original equation. And once you've done that, state all your valid solutions. So these steps will make a lot more sense when we go through and do a question. So let's look at this one here first. I have the absolute value of 3 plus x equal to 2x plus 1. So let's talk about the implied restrictions first of all. So let me just do this on the side here. Okay, so whatever this is, because it's an absolute value, the output of the left-hand side is always going to be positive. Since it's an equation, it will be equal to whatever that value is, has to be positive as well. So positive on the left, positive on the right. So I know that 2x plus 1 has to be greater than or equal to 0. Subtracting 1 from both sides, 2x greater than or equal to negative 1. Dividing both sides by 2, x greater than or equal to negative 1/2. So that's my implied restriction, and that's for the whole question. So whatever answer I get, it has to be greater than or equal to negative 1/2. Now let's talk about the piecewise function. So that absolute value needs to be written as a piecewise function. To do that, I need to look at what's on the inside, which is this 3x plus 1. So I do a little sketch. All I care about is where is it above 0 and what is the x-intercept. So I want to write this as a piecewise function. So positive 3x, absolute value of 3 plus x is going to be equal to, we have a positive piece and a negative piece. So let's focus on my positive piece first. So positive piece is where it's above the x-axis. When I take the absolute value of a positive, it stays positive. That is going to happen to the right of negative 3. So positive piece means it stays the same, and that happens when it's greater than or equal to negative 3. Okay, let's look at our negative piece. So our negative piece is where we're below the x-axis, and that is negative. My function's negative there, but the absolute value of a negative is a positive. So this is my reflecting piece, and that's going to happen to the left of negative 3. So to show that it's reflected, I multiply the entire equation by negative 1, just making everything opposite. So the opposite of 3 is negative 3. The opposite of plus x is minus x. And that will happen anytime x is less than negative 3. So now that I have my piecewise function and my overarching implied restrictions, I'm ready to solve. And what solving is going to look like is I am going to replace this absolute value. I'm going to replace it with the positive piece, and then I'm also going to replace it with the negative piece. By replacing each one of those, I don't need the absolute value anymore. So here's what it looks like. My first equation, my positive case, is that 3 plus x equals 2x plus 1. My negative case is that negative 3 minus x equals to 2x plus 1. Notice this stays the same. There's no absolute value here. This is constant. It is unchanging. So in each of the equations, you'll notice that I have my 2x plus 1. That doesn't change. What changes is the absolute value. And then the overarching restriction for the whole question is that x has to be greater than or equal to negative a half. So now that I have my cases, I'm going to go through and solve. So they are nice linear equations. So I'm going to subtract x from both sides. X take away x is 0. So I'm left with 3 equals 2x minus x. I'll subtract 1 from both sides. 1 take away 1. So I end up with 2 equals x. So I have the solution that x equals 2 in the positive case. We need to check that in 2 places. First place, here. Is x greater than or equal to negative 3? Yes, it is. So the subdomain is okay. Then I check it in my big restriction. Is x greater than or equal to negative a half? Yes, it is. So it looks like x equal to 2 is a good solution. To know for sure, I would check it on the calculator. Okay, let's look at my negative case. So again, I want x on one side. So I'm going to add x to both sides because x take away x is 0. So I'm left with negative 3 equals 2x plus x plus 1. So I will subtract 1 from both sides. Negative 3 take away 1 is negative 4 equal 3x. So 3 times x, I'm going to divide by 3. That's the opposite. So that means that x is equal to negative 4/3. So negative 4/3 is negative 1.3 repeating. So I'm going to check that in 2 places. First place is my subdomain. X has to be less than negative 3. Well, is that true? Negative 4/3, which is negative 1.3 repeating, is not less than negative 3. So that means that this is not a solution. It is an extraneous root. So in the negative case, I do not have a solution. It is extraneous. Now let's talk about how I might have noticed that without actually solving. So I just want to highlight something for you. The overarching restriction is that x is greater than or equal to negative a half. So whatever I get, it has to be greater than negative a half. My subdomain for the negative case is that x has to be less than negative 3. So if we compare these two here, there is a contradiction. They contradict each other, okay? So it can't be greater than negative a half and also less than negative 3. So anytime this happens, if you ever notice it, if you notice that the restriction and the subdomain contradict each other, there will be no solution in that subdomain. So it looks like the only solution I have is that x is equal to 2. So here's my check. In the original equation, left side in y1, right side in y2, start the table at 2 and you can see that they're equal. So that tells me x equals 2 is the solution. Okay, let's look at this one here. Solve this one algebraically. So step 1 is always get the absolute value by itself. So I'm going to subtract 12 from both sides because 12 take away 12 is 0. So I'm left with the absolute value of 3x minus 4 equals to 9 take away 12, negative 3. Now, when I look at this, I have an absolute value on the left side and a negative value on the right side. Well, that just doesn't make sense because absolute value functions are always positive. So since that's not true, we can't even solve this because there's actually no solution. It is impossible to find a value of x when I substitute it inside an absolute value and have it equal to a negative number. Okay, let's try this next one. So solve this algebraically. So again, step 1 is going to be put my function inside my absolute value into the calculator to find my x-intercepts. Okay, so my x-intercepts are not nice numbers, but this is just for the piecewise function, so I'm okay leaving them as a decimal because those are not solutions, they are just the subdomain. Okay, so I want to look at the positive piece and the negative piece. So let's look at the positive piece first. So the positive piece where it is above 0, where the function is above the x-axis, right in there. All of these have a positive function value, and the absolute value of a positive stays as a positive. This will happen to the right of 0.1 and to the left of negative 3.6. So the absolute value of 2x squared plus 7x minus 1 is equal to 2 pieces. So the first one is the positive piece, which stays the same. 2x squared plus 7x minus 1, and that is going to happen when x is greater than or equal to 0.1 or when it is less than or equal to negative 3.6. Okay, let's do the negative piece. So the negative piece where it is below the x-axis, all in here. All of these points here, the function is negative. The absolute value of a negative is a positive. So this is my reflecting piece. And that's going to happen in between 3.6 and 0.1. So to show that it's been reflected, I multiply the function by negative 1, which just switches all the signs. So 2x squared becomes negative 2x squared. Positive 7x is negative 7x. Negative 1 is positive 1. And that will happen in between negative 3.6 and 0.1. Okay, so now that I've listed it as a piecewise function, I'm going to look for implied restrictions. And you can see that the left-hand side, because it's an absolute value, is always positive. And the right-hand side, since it's a constant value of 3, is also always going to be positive. So there are no implied restrictions, since both sides will always be positive. So let's look at solving the two different cases. So let's solve my positive case first. So for my positive case, I replace the absolute value with my positive case. So I just replace it with that value there. So instead of having absolute value, I just have the function 2x squared plus 7x minus 1 equals to 3. So it's a nice quadratic. Set it equal to 0 by subtracting 3 from both sides. So 2x squared plus 7x minus 4 equals 0. So this is a quadratic that can be factored, so I'll just go ahead and factor that. So this is 2x, x, 4, and 1, positive and negative. So let's set each factor equal to 0. So 2x minus 1 equals 0. Add 1 to both sides. Divide both sides by 2. Here, x plus 4 can equal 0. Subtract 4 from both sides. X is negative 4. So I'm going to check this into the subdomain, and then I can check it on my calculator after. So x has to be greater than or equal to a half. Well, sorry, x is equal to a half. X has to be greater than or equal to 0.1, so this is good. My second subdomain is that x has to be less than or equal to negative 3.6, and that one works as well. So it looks like both of those are in the running for a good solution. Okay, for my next one, I'm going to replace my negative case with the absolute value. So when the input is negative, this is what my equation would look like. Okay, so again, it's a quadratic, so I'm going to set it equal to 0. So I'm going to, because my leading coefficient is negative, I'm going to add 2x squared to both sides. Add 2x squared to both sides. I'll add 7x to both sides and subtract 1 from both sides. So doing that to both sides just to get it set to 0. So this is now all 0. So I have 0 equals 2x squared plus 7x, and 3 take away 1 is 2. Now this cannot be factored, so I'm going to have to use the quadratic formula. So x is equal to opposite b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So x is equal to negative 7 plus or minus the root of, so I'll put all of this into my calculator. So I have 7 squared minus 4 times 2 times 2, which is 33, all over 4. Now, I don't know if that satisfies the subdomain because I don't know exactly what that number is. So what I'm going to do is I'm going to put this into my calculator just to figure out what each of those values are. So let's go into our calculator and do exactly that. Okay, so in my first one, looking at here, I need -7 plus root 33 over 4. So I have -7 plus the square root of 33 over 4. So that's my first one, and let's come back up here and grab my second one, but we're going to change it to a minus. There we are. So I want to know if these values meet the subdomain. So I've got -0.3 rounded and -3.2. So here it's -0.3 and the other value -3.2. So you can see that satisfies the subdomain. So those are also both good solutions. I do that just to check. So I'm just going to erase that. It satisfies my subdomain, but I don't want to leave my answer as a decimal. I want my answer to be as an exact value. Okay, so I have 4 solutions, it appears. This satisfies the subdomain. So I just have to put this into my calculator to see if it works. Okay, so there I have the original equation, left side in y1, right side in y2, and you can see the check always happening in the table. I start my table at each one of those values, and they all work out to be true. So that tells me that this is my final solution. -4, 1/2, and -7 plus or minus root 33 over 4. Okay, I just want to end with a word problem. So a computer controls the amount of cookie batter used. If the program sets the ideal mass at 55 grams, but allows a tolerance of plus or minus 2.5 grams, find the max and min mass of batter. Now, when you buy something and it has a weight on it, it doesn't mean that's the exact weight. There's always a little bit of a tolerance or a percentage error. So it's kind of on either side. So when it says 55 grams, technically it could be on either side of 55, or maybe you'll luck out and it will be exactly 55, but that doesn't always happen. So what we're going to do is m, the mass, minus the amount equals to the tolerance. So here's what my equation is going to look like. The amount is supposed to be 55 grams. The tolerance is 2.5, plus or minus because it's on either side. So here's my equation. The absolute value of m minus 55 equals 2.5. So step 1 is going to be to write the piecewise function. So I go to my graph to do that. And again, on my graph, I only care about what my graph looks like and like where it is above and below 0 and what the x-intercept is. So using my graph, I'm going to write my piecewise function. So the absolute value of m minus 55 is equal to, and let's do our positive and negative pieces. So here's my positive piece where it's above 0. And the absolute value of a positive stays as a positive. That will happen to the right of 55. So that means that my function stays as m minus 55 anytime m is greater than or equal to 55. Okay, my second piece is the negative piece where it's below the x-axis. And in here it's negative, and the absolute value of a negative is a positive. So switching the signs, m becomes negative m, negative 55 becomes positive 55. And that will happen anytime m is less than 55. So now that I have my piecewise function, let's look for implied restrictions. On the left-hand side, the absolute value output is always positive. On the right-hand side, it's a constant value of 2.5, so it is always positive. So there are no implied restrictions. So now I can solve each one in the subdomain. Okay, so the positive case, replacing my absolute value with my positive input. So to solve this, I would just add 55 to both sides. So then I have x equals 55 plus 2.5 is 57.5. Okay, in my negative case, oh, let me check the subdomain. I almost forgot. It has to be greater than or equal to 55, which it is. That's good. No overarching restriction. So my negative case, solving this, I'm replacing my absolute value with the negative input of negative x plus 55. So what I'm going to do is I'm going to add x to both sides because I want x to be positive. So x take away x is 0. So 55 equals x plus 2.5. Then I will subtract 2.5 from both sides. So that's equal to 0. And then on the other side, I just have to do 55 take away 2.5 equals x. Again, check that in the subdomain. X has to be less than 55, and that also works. So what this tells me is that the minimum mass is 52.5 grams. Don't forget your unit. And the maximum mass is 57.5 grams. Okay, so this little joke here, I actually kind of made it up, so I hope you think it's cute. The absolute value factor. So the absolute factor, tonight on the absolute factor, is it cold in here or is it just me? Because it's absolute value minus 11. Funny? Not? I don't know. You tell me. So you guys can work on practice questions 2 and 3, and then you can move on to the textbook questions after that. So I hope this video helped, and I look forward to seeing you guys for the next one.